So this will be the first question in this series of questions, and this was actually the first question asked. So as we can see here, we are given a string S, and we need to determine the minimum number of operations required to make the number of vowels and consonants equal. An operation is defined as the conversion of a character to another adjacent character, nearby character. So we can convert A to B and C to D, but if you want to convert A to D, we have to go through A to B, B to C, and then C to D. So a total of three operations. So we need to calculate the number of vowels and consonants first. We declare two variables, vowels and consonants, and initialize them to 0. And as we traverse the string, when we come across a character, each character, we classify them either as vowel or string, like consonant, right? How do we do this? I have taken a list in Python and I have appended all the vowels in here. So for each character, I check if it is in this list or not. If it is in this list, then I increment the vowel variable, or else I increment the consonant variable. You can also do this using set in CPP or map in CPP, also dictionary in Python. Um, so if we look at the sum closely, we have got the number of vowels and consonants. There can be three cases. Since we have got two values, they can be equal. Vowels can be equal to consonants, or vowels can be greater than consonants, or consonants can be greater than vowels. So we have got a total of three cases. So that is what I have written here, and I have also written the alphabets in order and their respective numbers as well. Mm, this will actually like help us a lot when you are solving questions like this. And coming to the first case where vowel is equal to consonant, the question asks us to make the number of vowels and consonants equal, right? We already have them equal, then we just written 0 in this case. The question is already satisfied. Coming to case 2, we have got vowel greater than consonant. Vowel is greater than consonant here. So what we need to do is convert vowel to consonant. Vowel to consonant. We have to take one element, one vowel, and convert it to a consonant. So the number of conversions will be, what we have to keep in mind is when we convert one vowel to a consonant, the vowel decreases and also the consonant increases. So we keep doing this, which means the vowel keeps decreasing and consonant keeps increasing until they become equal. So the number of conversions will not be vowel minus consonant. It will be vowel minus consonant by 2. And if you look at this order I have written here, I have marked all the vowels here, A, E, I, O, and U. But what we notice from here is that no two vowels are together, right? There is always a constant in between. So we can infer that the minimum number of operation to convert a vowel to a consonant is always 1, because there is always a constant nearby, either to the left or to the right. There is always a constant nearby. So we just return vowel minus constant by 2 for case 2. That's what I have written here. Let's say we have got 5 vowels and 3 consonants, and 4 vowels and 4 consonants. We take one vowel and convert it to a constant to get 4 vowels and 4 consonants, and the value will be, answer will be vowel minus constant by 2. So the minimum number of operations will be 1 in this case. So coming to case 3 is quite interesting because constant is greater and vowel is lesser. Similarly, we take one consonant and convert into a vowel. But what is the difference here is that for the case 2, we always know that a vowel always gives 1, like the minimum number of operations for converting a vowel to a consonant is always 1. But in this case, we do not know because the minimum number of operations for converting a consonant to a vowel always differs. Let's take an example here. Let's take B here. The B requires one operation to be converted to A. That is the nearest vowel right here. We can compare B with A, E, I, O, and U. And if we find the operations for all of them, the minimum number of operations will be with A with respect to A, and the answer will be 1. Similarly for C, C satisfied both A and E. So the minimum number of operations here will be 2. So what we infer from this is we just cannot blindly return a value. We need to sort these consonants for these consonants based on their minimum number of operations required. So what we do is that we take for each consonant available, we take the minimum value of the number of operations with respect to A, with respect to E, I, O, and U. How do we find the minimum number of operations? If you see here, for B we have got a value of 2 and for A we have got a value of 1. So it is just 2 minus 1. B minus A will give you the like operations required. So what I have done here is ASCII value of C minus ASCII value of A plus 1. Like similarly B and A, C and A. For A we keep A here and check for all constant values here. Similarly for E, I, O and U. So we get operations required to be 2, and whenever we get this value of this uh, statement right here, we append this into a list or a vector in CPP. So what we end up getting is, let's say I've taken example of B, C and G here, because B has got one operation to be completed, right? B to A. For C it will be C to A or C to E. For J it will be J to I. So we have got to take the absolute value here. For the operations here, I forgot to mention, but we have to take the absolute value here because for C we are going both forward and backward. So we have to calculate C with respect to E as well as to A, but we have to keep the value positive. So we take the absolute value. So therefore, we just take the values and then append them to a list. We have got 1 comma 2 comma 1. What we need to do now is sort them. If we sort them, we get 1 comma 1 comma 2. So basically we have written down all the possible operations for all the possible consonants, sorted them, and we now choose only the minimum. Let's say the number of conversions we need to do will be consonant minus vowel by 2. It was vowel minus consonant by 2 for case 2, but for this case it will be consonant minus vowel by 2 because consonant is higher, right? So coming back, we now know that the number of conversions to be done is consonant minus vowel by 2, and so we take the first x values in the sorted array. If the number of conversions need to be done, if we need to convert two consonants to vowels, we just take the first two values, 1 and 1 comma 1. We sum them up and return the value. So as we can see here, we have got case 1, case 2, case 3. We have written 0 for this. We return vowel minus consonant by 2 for this, and we find the number of conversions in case 3, and then number of operations for each consonant, and then sort them in a list or in a vector, and then we return the first x value of the vector, where x is the number of conversions to be done.